All right, so maybe I should back up here and show you that I'm working on the review for test 846A, and I have had a request for page 8. Okay, I'm guessing that means all of them, since I didn't get any more information than that. So let me slide this down and see if I can handle this question. And let's see here. Use the properties of logarithms to expand the log. So if this is multiplication, we're going to split this up into log base 4 of 5 plus log base 4 of 2. We're using the multiplication property in reverse and splitting it up into addition because they're asking me to expand it. So guess what, folks? That's it. That's all we can do with that. Where possible, evaluate. Oh, they do. They threw this in. Where possible, evaluate. It does look like they're... It is ugly. I think I would take that answer. Because that other one's going to be like 0.5. I mean, we could do this part right here. Remember, we could... this one's going to be a nice number. Log base, oops, what am I thinking? Log base 10 of 2 over log base 10 of 4. I think that's going to be 0.5, right? Because it's the square root. Yeah, I don't want that. I don't want a decimal. Plus, the point of the question is, you know, can we expand it? That's really the point of the question, not giving me decimals. So that's what I want right there. End of story. Move on to the next question. Use properties to expand. Okay, so let's choose purple here. All right, so same idea. Log base 6 of 36 plus log base 6 of x. Truth of the matter is, that's expanded. I'm not going to worry about the simplifying part. We're just going to go with the expanded part and be done with it. Okay, now that's division, right? So we're not going to add, we're going to log base 3 of 3 minus log base 3 of y. And let's be done with it. We're just splitting it up. There's no exponents that need to be moved anywhere. Expanding means all of our exponents have to be 1. And it looks like in every single one of these questions, they all have exponents of 1. Yep, everything's got an exponent of 1. So don't have to worry about any of that. Otherwise, the King Julian property, I like to move it, would come into play. But it's not here. Okay, next page would be page 10. All right, page 10. Okay, so first off, I would change this using the change of base, right? Fill in the boxes, right, of this, change it into its log form. The base is 2, right? The exponent is 2x, and the only thing left is 17. Now, you and I both know how to handle this. We're going to write log 17 over log 2. These are the change of base formula. Of course, this is 2x over 1. And you can focus your attention on this thing. It's proportion. We can cross multiply that. Or you can just look at it as like this. You can divide that on your calculator, right? Log 17 over log 2. Find that value. Okay, let me grab a calculator. Sorry for yawning. Nobody likes a yawner. 4.087, and then we divide that by 2, right? Because in order to get rid of that 2, we would have to divide by 2. So it should come up with 2.04, approximately. 2.04 for your final answer for question 1. Okay. Suppose that a new employee starts working. They've given me $752 as the starting amount. We're increasing by 5%. So, we know, let's see, we know that would be 10 equals 7.52 times 1.05 to the t power. And we're going to divide out the 752. That's the first step, 7.52. And what is 10 divided by 7.52? 1.33. 1.33 equals 1.05 to the t power. So when it's in exponential form like this, we change it to its log form, right? The base is 1.05. The exponent is t, right? Logarithm means exponent. And 1.33 is the remaining value. Okay? Change of base to 10, right? So we can use our machine. Log 1.33 over log 1.05. And now we reach over and grab the calculator. Log 1.33, end parenthesis. Make sure if you're using a scientific calculator that you get this parenthesis in there. Otherwise, that one's going to be a killer. It'll change the value that you're dealing with. 5.85. 5.9, something like that. Solve the equation. All right. Is it a single logarithm? The answer is yes. So that's 10 to the first equals, right, because the basis of this is 10. The exponent is 1. So we have 10 to the first equals 17 minus 7x. Move the 17 to the other side by subtraction. That gives me negative 7 equals negative 7x. Oh, look at that. We're talking about an x value of 1. Page 11. Man, doing all kinds of work here today. So the 4x and the 1x get multiplied together because of the property about addition. So that would be log 4x squared equals 6. And, of course, then we will have to change that to its exponential form. Something to the something power equals something. So the base is 10. That's right, because you don't see it right there, right? The exponent, which is what logarithm means, is 6. Ooh, 10 to the 6th. That's like my bank account. Just kidding, folks. That is not like my bank account. 1 million, right? Divide by 4. So 250,000, and we want to take the square root of 250,000. Square root 500. Look at that. 500. Now, because this is subtraction, we're going to be pushing these things into a single logarithm of division. 5 over 4x equals 1. Now that it's a single logarithm, boom, time to change to exponential form. So the base is 10. You can see that because there's nothing written there. The exponent is 1, because logarithm means exponent. And and then 5 over 4x. Most people would like to see it written 10 equals 5 over 4x. Cross multiply, and we get 40x equals 5, and divide by 40. 5 divided by 40 is 1 over 8. They wanted its fraction, integer, or decimal. Ooh, 0.125. They want the decimal version. All right. Question 6. Oops. Scribble. 2 to the second power equals x. In other words, we were putting it into its exponential form. Base exponent equals x. Well, 2 squared is 4, so we're done with that question. Move to page 14. Okay, so log x plus 3 equals, what are we going to do with the x and the 3? We're going to multiply them together because we see addition in between. Since these are both equal and the bases of the logarithms are the same, so are the arguments. So we can set them equal to each other and solve, pushing this to the other side. Wait a second, it looks like I divided by 2 on one side and 3 on the other. Holy crud, that's weird. Yeah, that should be a 2. A 2 we could divide by. So we subtracted an x, divided by 2. Okay. So 3 over 2, or 1.5 if you're a decimal fan. So what are we going to do with the x plus 10 and the 2 since we see subtraction? We're going to divide them. Equals log of 3x plus 2. Once again, logarithms are the same, so are the bases. So x plus 10 over 2 equals 3x plus 2 over 1. So we can cross multiply. X plus 10 equals 6x plus 4. And go through the process, 6 over 5. That should be good. Hopefully I've done everything correctly. And is this page 14, please say it is? Yeah, that was page 14, and we're done with the questions that I've been asked about from the review for test 846A.